everyone. Thank you for coming to this breakout session, part of the NTI Sustainability Summit. Today, we're going to be looking at sustainable manufacturing and insights. My name is Matt Oosthuizen. I am a sustainable manufacturing specialist here at Autodesk, part of the Impact and ESG organization. A little bit about me before we get into the presentation. I have a mechanical and manufacturing engineering degree. I've been working at Autodesk for around 3.5 years now. And my main role at Autodesk is delivering new solutions for sustainability in design and manufacturing. And really, I'm a big advocate for additive manufacturing within the industry, as I see it to be the technology that's going to help us bring more sustainable manufacturing workflows to the consumers. Before we get started, just wanted to do a quick safe harbor statement. There's some prototypes and beta release versions of some of our solutions. I just wanted to say, don't make any purchasing decisions based off what I'm showing today, and take everything that I say with a pinch of salt in terms of timelining. Great. So the schedule today, we're looking at the industry's impact. Then we're going to talk about Fusion 360's Makersite integration, our new manufacturing sustainability insight tool. Going to go a little bit about generative design. I know that majority of people here will know about that, but then we'll also look into a new tool by Autodesk Research called the Digital Materials Engineer, and I'll be showing a prototype about that. Right. Now, as the world develops, the world's demanding new ways of living, working, designing, and making things. And really, we're seeing this by 2050, we're going to be 10 billion people on this planet, resulting in 50% more energy demand, 50% more resource demand. Really, with that population growth and the acceleration in urbanization, we're going to need to be able to fulfill that, and we need to do that in a sustainable way. And the way that that's possible is by you, people watching this. You design and make the world around us. And if we can leverage technologies and manufacturing processes to design and make more sustainably, we can impact that amount of resources required and meet that extra demand. And this is being echoed by executives and big corporations. Studies have shown that around 41% of executives identify that decreasing waste from production and using more recycled materials is already happening in industry and is making industry more sustainable. And Autodesk customers, about 73%, have sustainability as a component in their strategic vision. Now, really, we're seeing consumer demand for more sustainable products, and this, paired with environmental regulations, is really pushing for designers, manufacturers to require more sustainable incomes. And really, we want to be able to provide that level of solutions to our customers so that they can design, manufacture, produce, and operate more sustainably. And the key challenges that we found within the industry of design and manufacturing is that operational energy, the opportunity. We need to be able to improve the performance of our factories, our machines, our products. We need to optimize our energy consumption and reduce our waste. And the products that we design, there needs to be some form of circularity evolved in them. We need to design our products through material choices, durability, and disassembly to ensure that they are circular and they don't go end up in a landfill somewhere. From a material standpoint, we need to understand materials better and what their trade-offs are in terms of selecting them for manufacturing, for mechanical use, for recyclability. And then we also need to ensure that we have supply chain resilience. There's lots of things happening in this world now, making sure that if we have supply chain resiliency, we can meet our demand easier. But then also we need to have traceability. We need to understand where our materials are coming from, what impact they have, and their reliability when they're being used. And then finally, I think a key point is the demand for green skills. As young engineers come out of university, young designers, manufacturers, we want to ensure that they have that ethos of sustainability embedded in them. And that's really reliant on education and showcasing and leading from the front. Now we can see that the things that we make have the biggest impact, with 31% of total greenhouse gases coming from what we make, and 80% of that greenhouse gas is locked in at the design phase of product development. Now, if we look at a graph here from the infrastructure carbon review, we can see that 80% is locked in that design phase, with 20% in manufacturing. And really what this means is if we can design some more smart and produce more efficient products, we can significantly reduce the amount of carbon emissions of that component when it gets to its tail end, when it is in its implementation and its operational and maintenance phases. Now, this is quite like daunting, and I understand that. However, we can break it down to be more simple. And really, in our team, we talk about this in 4 key areas. Sustainability can be broken down, if you want to generalize it, is quite simple. All that we need to do is we need to use less energy, we need to use better energy, we need to use less materials, and we need to use better materials. And we really focus on developing solutions so that we can help designers and manufacturers to do this. And that's what we're going to look at today. Now, when we're making a change, we want to understand our manufacturing impact. I whipped up a quick case study and a data set to look into this and wanted to showcase some of the new sustainability solutions that we have for Fusion 360. We're going to go through the Makersite integration, manufacturing sustainability insights beta, generative design workflows, and look into the future with a demo from Autodesk research. So we have a consumer product here as an example data set, a little F1 car toy. We're going to use that to showcase our different solutions. Now let's get started with Makersite. Now, what Makersite does, its key features, is real-time BOM-based carbon and cost analysis. We have a heat map view to isolate the problem areas. We have a design history, better material suggestions. We have analysis for Makersite, its platform itself, so you can take this further. Now, let's go into the actual demo and I can talk over the process. So once you've downloaded Makersite from the App Store, you can start by sending a bill of materials to the Makersite backend. And what this does is breaks down all of your design tree, the components, and produces a carbon value for each one based on the materials. So we have a breakdown of global warming potential, the amount that you could save by having replacement materials, how much it will cost, and what the carbon is. And it's broken into this table view. But if you want to use a heat map view, let's say you have a big assembly, thousands of components, and you understand where are your key areas to focus on for carbon reduction. It's color coded in which areas have a higher carbon concentration compared to others, and that should hopefully help you pinpoint quicker. You can see here the wheels and the chassis of this toy are the key areas that we want to focus on from a material selection and a design standpoint. And same thing with cost. We have the same breakdown of how much it would roughly cost to mass manufacture these products. Now, if we go into the list view again, we can compare all of our bodies, but then also understand what is the material that we need to change to be able to minimize the carbon emissions straight away. So we can see that this front block, it's currently made out of nylon 6, and Makersite is suggesting to change to a polypropylene instead to reduce by 81.6%. So we can go and do that, change that. For aluminium, we're going to keep it to 6061 aluminium, but for the other parts like the rear block, Makersite's actually suggesting a ABS with recycled material content. Now, the great thing about this add-in is when you make changes in Makersite and you apply that selection, it will overwrite your materials that are in Fusion 360, so that there's continuity between your Fusion 360 model and also what you have in Makersite's backend. So you can see there, we've applied it. Now we want to save the model, and what it will do is resubmit the bill of materials so that the carbon calculations have been updated on the add-in here, and we'll be able to see those changes in the history view as well. There we go. You can see it's reduced by about 90 grams of CO2. Not a massive change, but we knew the key areas of those wheels that we'll take a look at later. Now, see it going into the history view. There we go. See it updating. So now we can see how it's changed over the last 3 designs, how that's impacted our CO2 emissions. Great. Now we can take this one step further and think, let's optimize those wheels because they were where majority of the CO2 emissions were. So we're going to go to manufacturing sustainability insights. And this is a new beta that we're releasing or have released that gives real-time component carbon analysis based off manufacturing process, location, and material. And we have way more manufacturing processes and materials that will be added to this add-in later. Great. Let's go back into Fusion. And once you've downloaded it, it will be in the Inspect tab of Fusion. You can see Manufacturing Sustainability Insights. And now we have a breakdown here of we can select a body to analyze and to set our MSI parameters to. So we're going to select the main body of the car. We can select the manufacturing process, so subtractive or additive. We can then compare our materials. So it automatically takes a closest known material. So we had polypropylene in there, so it gave us polypropylene. But if it's a fringe material, it will select something for you. And then we have our location. So we selected Europe for manufacturing. Now in the compare process, we can see how additive compares to subtractive, where that carbon sits and where do we need to make reductions. So if you saw in additive, majority of the CO2 emissions was based in the manufacturing process, in that energy consumption, whereas subtractive is heavily dependent on the embodied carbon of the material because you're using a less material efficient manufacturing process. So as I said, as this goes into production, we'll have more manufacturing processes to show and more materials. The history view is every time you save a change, it will upload that and you can see as you've made design changes, as you've made material or manufacturing process changes, you can compare those together. There you go. You can see now that we've done additive polypropylene in Europe, we can see how that's reduced the carbon emissions by around 200 grams from subtractive polypropylene made in China. Now, if you wanted to make design changes on the fly and see how that impacts your CO2 emissions, we have a persistent view. Now, what this does is it floats around and you can highlight a body and it will then calculate the CO2 emissions based off of the MSI statistics or settings that you've chosen. So for here, for the wheel, we're going to be using subtractive manufacturing to produce these. We're going to do that out of aluminium and we're going to manufacture them in Europe. And we can see here that majority of that CO2 emissions is locked in with the materials. So if we have a circularity, process in place, we can recycle that swarf and that waste coming from it. So really, if we can reduce the actual embodied carbon of the component, we can reduce the overall CO2 emissions. Great. You can see there also by highlighting each of these bodies, it then does a sum value. So if you had multiple components in there, you wanted to get a full assembly analysis, it will highlight it. And then based off of your settings for each of those components, it will calculate the CO2 emissions. Now, the next bit we're going to go is sped this up, but I'm going to make some design changes. And you'll see every time I highlight the component, it will give a carbon value. And I'll put that on the bottom left of the screen so that you can track how the design changes have impacted the overall CO2 emissions of this particular wheel. So yeah, sped it up so that you're not judging the way that I CAD, but we'll get there in the end. So my main focus here was to lightweight the part initially and then do any aesthetic changes, keeping all of the key areas. So we can see first version where it was a solid wheel, about 5 kilograms of CO2 to manufacture it, whereas version 2, by hollowing it out, reducing the amount of actual material in the part because we are recycling, go to 1.8. Now we're going to go and lightweight it a little bit more, some aesthetic, get some spokes in there, goes to 1.5 kilograms of CO2. And now this is really just cleaning up, making it look good. We've done a lot of savings here already, reduced it significantly. So now let's make this wheel look good. Make your something proud of your toy. Great. So when we finish this, we can compare that. Now this ends up to be around 1.6 kilograms of total CO2, which gives us around a 42% reduction in our overall emissions. When comparing it to the whole assembly. So the whole assembly was around 24 kilograms of CO2. And now with this reduction, we're getting down to around 14 kilograms. So that 42% total savings. This is really how we envisioned the customer using the Maker MSI add-in. But feel free to download it for yourself from our insider program, scan the QR code or contact us and we can send you a link and play around with it and give us feedback. We're looking to do an R1 release with more manufacturing processes and materials in the next couple of months as well. Great. Now we're going to move on slightly. We did some manual manufacturing changes there with my design skills, but we're going to look at how generative design works and how that could be validated with a tool like MSI. So we have the starting design. We know it's 4.9 kilograms of CO2. We're going to use generative design. Generative design is a design process in Fusion where you can create optimized components that are minimized in mass whilst withstanding the environment that you put it in. So the load cases, the material, etc. So it's a really good solution if you wanted to significantly optimize your component for its loads. Now, the way that works is you start with a geometry, then you define your preserve and obstacle geometry. So we want to have the thread of the tire or the outer of the tire stay the same, but the inside, we can't have any material where that gets added to a bearing. Then, once you've defined it, you can apply load cases and then submit that generative design study. I cut it into 5 sections, or 6 sections, just so that I can then make it symmetrical and it's less computation for generative design study to do. Define the materials. We're actually using additive manufacturing now instead. And then you can generate your GD results. So we can see here every frame it's changing and growing or coming from that starting point to ending up with something that's been optimized. Great. And then finally, we can end up with our final design. So we have our GD wheel here, or it's reduced significantly in mass, and our overall carbon impact of it is 0.5 kilogram of CO2. So we can see that process that we can use MSI in to validate the sustainability claims of your generative design outcomes as well. Perfect. Just like I said at the beginning, the next one is a prototype that the research team here at Autodesk has worked on, and just take it with a pinch of salt. Can't say when this will come into product. Don't make any purchasing decisions off of it. So now I'm going to show you the digital materials engineer, a prototype that the Autodesk research team has been developing over the last year. The prototype leverages the ANSYS Material Universe database, and it has over 4,000 different materials with 694 carefully curated attributes. That's millions of data points that only an expert in materials could really navigate correctly and pick the right material for a certain use case. But a lot of our customers aren't materials experts. They're designers, they're engineers, they're manufacturing specialists. So the digital materials engineer is really here and has been developed to be able to lower that barrier of entry and help designers and engineers understand their material impact and pick the best material for their concept, for their part that they're creating. Now, we're going to use Bon, who's an Autodesker, to showcase how the workflow would happen. Now we can see here, Bon's working away on his computer. He's designing, coming up with a design. He's designing a watch case, and he wants to find the best material to manufacture that case. Now he can navigate the digital materials engineer, and you can see that the workflow is very left to right. So you start with your describing your requirements, you refine them, you then visualize that, selecting the right material for you, and then you compare them all together on the right-hand side. Now, this starts off by using 2 types of artificial intelligence that have been refined and trained internally. So start off with your prompt. So you have I want to design a watch case that employs lightweight, low cost, high strength, sustainable materials, and that then generates a brief from that. So it can identify, okay, you want lightweighting, so we're going to give you this value. You want cost, so we know that it's going to be lower than this. High strength, you want renewable because you want sustainability. It's got it can understand that you want sustainability, and it gives you recyclability and then low embodied carbon. Now, the next stage is to refine your requirements. So validate what the AI has given you, and you can compare and see how you change your requirements, how that impacts the materials that you can search through. So we can see when Bon goes through, he can select which material or requirements he cares about, which is being generated by the brief, and then you can make those changes. You can see how that highlights certain materials in material families that he can identify and go and interrogate to see if they're the right material for him. Now, after that, once he's nailed it down, he's got aluminium, magnesium, and titanium here, he can then compare them side by side and understand exactly how do these two aluminium or titanium grades or alloys compare to each other. And this is really the important thing. It's narrowing down which material is best for your product, but then also which material or in that material group is the right one for you to be sourcing, bringing in-house and manufacturing with. And that's really where the digital materials come into play. It's being able to provide that level of insight to the designer without having significant materials engineering expertise. So hopefully we've done a good job here to take you through the new carbon solutions and sustainability solutions that we're developing here at Autodesk, and gets you excited that really we don't need to be stressed about the amount of carbon emissions that we're producing, because we are creating solutions to help people understand that. And really it's people like yourselves that can make that possible. So hopefully we've gone through that and corrected everything and you're happy. So have a think. How do you design and make the world better? How do you use tools like we've created today and workflows that can reduce the global carbon emissions of your industry? Thank you very much for listening, and feel free to send me an email if you have any questions about the solutions, and sign up to our insider programs. Cheers.
Hello, my name is Søren from NTI Denmark, and now we'll be answering questions coming in. And the first one is from Chris Kubin. Is Makersite only available for Fusion 360, or is an implementation to Inventor also possible? Sorry. And Justin Allen and or Audrey will be able to answer this, I think.
Yeah, currently the Makersite plugin is only available for Fusion inside of the Autodesk technology suite. I honestly don't know whether there are plans to expand that offering, maybe and look at Inventor, but currently it's just the Fusion platform.
Yeah. Okay, and of course you can still ask questions if you want. There's another one from Matthias Larsen. How is the carbon footprint calculated? Are different manufacturing methods taken into account?
I can answer that one basically. So the manufacturing space I'm standing in and supporting, but yeah, there's a number of ways that the embodied carbon is calculated. Primarily it's looking at things like the material volume and the density, and then applying that against the carbon factor from the material database. But there are other aspects where materials are coming, via length, or other areas where you may be getting a component that's already pre-manufactured coming in that consists of multiple other types of material. So then you'd be looking at EPD data, which gives an overall carbon value, and you then consume that overall number into the design.
Okay, hopefully that's answering the questions for you, Chris and Matthias. If there's any other questions, please write them in the chat right away, and then we'll take care of that. Otherwise, we'll begin to wrap up. And of course, if you have any questions coming off after this day, you can always write or contact your NTI local NTI partner, and then ask any questions you have. So
actually, I've just noticed Matthias's question is also around the different manufacturing methods. Now, I stand to be corrected on this, but I believe Makersite does take that into account. So whether you're looking at additive or subtractive, it does adjust for that. Now, that doesn't affect the embodied carbon of the material you're working with. That's still calculated for argument's sake on the overall volume of the material. And it may look at the wastage as scrap as well. The manufacturing method, okay, that is a form of embodied carbon where it is driven through the operation of the manufacturing process. So the energy that's being used, for argument's sake, to drive a milling machine or a 3D printer, and obviously that varies, those technologies vary. So that is, I believe, taken into account in Makersite, but it's a separate calculation to actual material carbon factor.
Yeah.
Yeah.
I actually have a question also. Matt, he also told that this is a beta version, but and he couldn't put any timeline on when will this be available. But do we have any clue about, will it be within a year or half a year or?
They're working on it hard.
Because it's very exciting features. Yeah.
Yeah. So I don't have an update more than that, to be honest, but this is a high priority that's being worked on.
But it is possible to try it out on the beta version.
Oh yeah, absolutely. Yeah.
Great.
And it's super easy to use. That's, and that's, we talk about all sorts of these tools that are out there on the marketplace. And for me, simplicity in the user interface is key. I don't want to have to go through a whole load of training and use a product constantly in order to remember how to use it. Yeah. And I really think, the Fusion platform is so simple. And Makersite itself, I had no training, opened it up and started evaluating embodied carbon in my demonstration earlier on a solar panel. And it was it's just, easy.
What about you, Ellen and Audrey? Do you have any input or before we wrap up?
I would say I completely agree with Justin. It really does come down to ease of use. Nobody wants to work with something that's going to be complicated. No one has time for that. And I think the MSI integration is very similar. Incredibly easy to use. You can use it to be able to automatically calculate the embodied carbon of the product that you're developing. And similarly, as we were talking about with Makersite, this is going to take into account the material, the manufacturing process, mass, geometry, and then that's also combined with a customs emissions factor from Gravity's purpose-built database. And that's going to incorporate industry-leading product knowledge and process data and data from scientific literature to create a really accurate piece of this. So I think the two pieces that come in mind when you're going to be doing this is making sure that it's easy to use and then that it's really incredibly accurate so that you're actually getting data that's going to make sense for your business and that you can act upon.
Great. There's another question coming in from Michael O'Donnell. What sources are costs obtained from? How do we how up to date, reliable are they?
That one I would have to come back to you on, to be honest. I believe it looks at the going industry rates. I don't know how often that is updated. Again, certain things are indicative, and I did it in my presentation earlier. Yeah, we want absolute numbers. We want the absolute embodied carbon and the cost that something's going to be. But also, it's key that during the design phase, we're able to do comparisons. Now, my real background is it's in the architectural space. And yes, when it comes to going into construction, I want to know the exact embodied carbon coming from a particular supplier of a type of concrete. Same thing within manufacturing, I guess. But whilst I'm designing, I don't care about the specifics. I want to know whether this is better than this or worse than what the trade-off is.
Yeah.
Getting the finite values, that I come to worry about when I'm actually going into construction. I guess the same would be for manufacturing.
Yeah, for sure. Actually, two more questions came in. That's good. Chris Jørgen Christensen asks, how is the carbon footprint of the raw material determined? It might be in the same line as the former question.
I can keep talking. I can let Audrey or someone else have a go.
I mean, I'm happy to. Oh, sorry, Audrey.
Go ahead, Alan.
Are you sure? I was just going to maybe try and attempt to answer both questions from Christensen and Christian, in terms of how do you choose between recycled and non-recycled, and what is the carbon footprint? And I think there's an underlying question there, is that there's this like inherent want to know why something is being suggested. And so, why and where is that data coming from? And that's kind of where the digital materials engineer actually was born from. Looking at the previous two examples that Matt went through, a lot of these questions we found ourselves asking, like, is this data reliable? When has this data been updated? Who is doing this? Can we be meticulous in choosing and outlining specific recycled, non-recycled materials? So how the carbon footprints of raw materials is determined, basically it's pulled from a database somewhere. That's like the most low level, simple answer. Whose database, what their database looks like, and how up to date it is. Obviously, it usually is whatever plugin. So if it's Makersite, that'll be Makersite managing it. When you move forward to the next question, can you choose between recycled and non-recycled materials? Well, yes, that, at least from the digital materials perspective, we want to have that ability to give the user or the designer the flexibility to make those choices, because those are the questions that people are being faced with at the forefront. What do I need to do? Why? And suddenly all these other questions start flurrying through. So I appreciate it's quite a wordy response, but hopefully it gives a kind of bit of context as to why we're talking about these bits and pieces today.
Yeah,
I guess, yeah, that's great, Alan. And I guess just to add on to that one, the material databases themselves, they vary. So there are databases out there which are global averages. This material, the average of steel is X amount of carbon.
Yeah.
They get this by doing an average of the extraction of the raw material, what it takes in energy to process and create that steel, blah, blah, blah. And they come to this sort of global number. There are other databases out there which are more specific, and they contain environmental product declaration information. So this is saying that a particular steel supplier has broken that down further and got more accurate information on the embodied carbon through their transportation, through their own manufacturing processes. And they're certifying that. And that's where you get these subtle differences coming in.
Yes, I was just going to say, there's not a single source of truth out there for these measurements. I think we all wish there were, but that doesn't exist. And so, I think each of these might have their own backends a bit, but for MSI, it's powered by Gravity Climate. And our company is really committed to transparency. So all the documentation of where those numbers are coming from is in the product. And that means we're really going into industry bases and scientific literature and creating those custom emissions factors, as I mentioned before. You can literally click a button and it'll pull up the sources, because these calculations are only as good as the sources. But again, there are a lot of different sources to pull from.
Yeah. Let's see. No more questions. But I think you guys gave us a good insight and things and answers. So if no more questions is coming in, then I think we'll wrap it up. Do you want to say anything, Alan?
It looks like one more question may have just.
Yeah, I was just looking at a question.
Oh yes, yes, it did. Perfect. That's Jørgen Christensen again. How to manage the total carbon footprint?
Right. That's in manufacturing or in general? So total carbon.
Yeah.
During the different stages of production, you go through embodied carbon, which is the extraction, the processing to get a material like steel.
Yep.
Then you have the next stage, which in AC is transportation and construction. You'd have to take that into account. And that is where we start talking about the expanding the embodied carbon to different stages in the gates. During the life cycle of a building, you have operational carbon, the electricity, the energy it's utilizing all through its life. And then at end of life, decommissioning and pulling down. Manufacturing, again, same thing. It's kind of, you're taking a steel and you're making something with it. So you're in turn doing manufacturing operations, and they use energy. So if you're a manufacturer of, let's take a product, let's say an air conditioning unit, you need to account for all the embodied carbon in all the components of the materials inside of that air conditioning unit, plus the energy that was used in the machinery, the lighting, your people getting to work to make that thing. So everything goes into that to create this EPD, which says this air conditioning unit has X amount of embodied carbon in it. And that's the kind of like total wrap. You also have to specify what the energy usage of that air conditioning unit is over its lifetime. So if it's going to run for 20 years, how much energy you use, how often does it need to be maintained? So if you need to replace a filter, you need to start adding in the embodied carbon and the transportation to go and make those maintenance visits. That's the correct way of total carbon. I don't know, Ellen, if you want to, sorry, Audrey and Alan, if you want to jump in on that.
I would say, you know, at Gravity, what we're really working on is calculating a company's entire carbon footprint. So then it's even taking it that step beyond the product and taking a look at your operations as a business, your supply chain, all of those pieces. And we make a platform that makes that incredibly easy to calculate that information. So if anybody's interested in that higher level, please reach out. But yeah, there's many different stages of calculating your carbon footprint, and it's becoming more and more important. I mean, we've seen new legislations coming in Europe, like CBAM, meaning that you need to now not just account, you need to account for the entire data, and then soon it'll be costs levered on top of that as well.
Jürgen, we thank you for all the questions. That's great. Jürgen is asking again, can you take an inventor assembly with all the parts, put it to the NCAD/Fusion and get the right numbers? He says. Hopefully I understood your question correctly, Jürgen. Will anyone answer this question?
Sorry, I just lost my viewer there. Have you taken an inventor assembly with the parts and points to Fusion to get the right, to Fusion to get the right numbers? I would honestly have to defer to someone like Matt on the expertise on that one.
Agreed.
You can.
Can I focus on a particular part of that question?
Yeah.
I mean, in theory, you can move it across. I'm not going to talk about the workflow because it's been a while since I've done anything like that. But the right numbers, to me, kind of goes, well, there isn't necessarily a right number. What you should be asking is, does the number make sense to you? Is it relevant to whatever it is you're manufacturing? And be curious about those questions. Don't just take a number and go, cool, that's it, done. Always question it. That's what stuck out to me from that question.
You're right. You can definitely export from Inventor to Fusion, and basically what you're taking across is the volumetrics of the individual components, and it also does bring across the material assignment. So therefore, you should be able to run the analysis. Yes.
Yeah. So let's see. Just one more minute. So if you have any question, please type it in the chat, and then we'll take it. Otherwise, you can always contact us afterwards. No, I think that's it. So thank you, everybody.
Yeah, thanks for
thank you, Justin, Alan, and Mark. Yeah, and thank you for all the good questions.
Pleasure.
Have a nice day.
My pleasure. Have a great day, everyone. Thank you.
Guys.
Bye.